This is GCSE Physics, Electricity Lesson 12, and this is Mains Electricity ACDC. So we're going to understand the difference between alternating and direct current and establish a basic understanding of mains electricity. So first of all, direct current. So cells and batteries supply electrical current, which always flows in the same direction. And we call it direct current, or DC. So close the switch on this very simple circuit, and the current will flow in one direction only. So direct current always flows the same way. What about alternating current? So an alternating current, AC, is one which is constantly changing direction. So this is how we denote an AC power supply at the top with the curved line like this. That means AC power supply. So we'll close the switch on this one, as you can see. Alternating current constantly changes direction. And the lamp in that circuit would work with either AC or DC. Okay, so what about mains electricity? So the electricity supplied to our homes is called mains electricity. It is an alternating current supply. And in the UK, the current changes direction every 1/100th of a second. So this means it completes a complete cycle of changes every 1/50th of a second. So imagine it's going in one direction and then it flips to the other direction and then back. That happens 50 times a second. And we call it frequency. So mains electricity has a frequency of 50 Hertz or 50 cycles per second. Remember to pause at any point if you wish to make any notes. So we're going to more detail on this one next lesson, but the live and neutral terminals. So UK mains voltage is rated at about 230 volts. So that's an average. It actually fluctuates between a plus 325 volts and minus 325 volts. And we'll look at that in a moment. So UK mains supply is rated at about 230 volts. This means that it has the same effect as a 230 volt DC battery on devices like a lamp. So one side of the AC supply changes constantly between plus 325 and minus 325 volts. Regarding the plug itself, the socket, the bottom right is the live terminal. Touching that terminal can be fatal, so that's not advised. The other terminal remains around 0 volts, and that's called the neutral terminal. The top one's called the earth, and we'll look at that again in subsequent lessons, moving onwards. So voltage variation of the live terminal. So the voltage of the live terminal varies sinusoidally. If you've done maths, it basically means like a sine graph. So repeating function. The sine graph's a repeating function between plus 1 and minus 1. If you're not in year 11 and not done that, don't worry. It just basically means it'll repeat. You'll see in a moment. So it goes between plus 325 and minus 325. So that would be mains electricity. And we're going to do a calculation on the next slide. I'm going to show you how to do something. So I'm going to show you how to calculate the frequency from a voltage time graph like this one. And it's pretty straightforward. So what you need to do is look at the time period. Now the time period is the time for one full wave. So one full wave in this instance is where it starts. So let's go from this point. I'll try and do this as neatly as I can. And that's half a wave and a full wave. So the full wave is a time period of 0.02 seconds. And then to get the frequency is really straightforward. So if you ever see this, you can just do this. So frequency is 1 over t. And that's it, just put the numbers in. So it's 1 divided by 0.02. If you put that in your calculator, you will get 50 Hertz. And that's it. Pretty straightforward. So find one wave, get the time period, and then just do 1 divided by that time period. Make sure it's in seconds, and that will give you the frequency in Hertz. So in this instance, 1 divided by 0.02 is 50 Hertz, which is the frequency of mains electricity. We've just got one more thing to finish, a bit of a recap, consolidation exercise. But before we do that, this could be seen as a readout on something called an oscilloscope. If you're not sure what an oscilloscope is and you've not seen one at school, if you've ever been to a hospital and you know you have a heart rate monitor and it goes beep, beep, that's basically an oscilloscope. But oscilloscopes would, it is and it isn't. So basically you would get voltage against time on an oscilloscope. Let's move on then. So if you want to have a go at this one, if you don't want the keywords, you can pause and attempt this now. You can either write this out in full so you've got some comprehensive notes, or you can just write 1 to 9 and put the keywords in the correct place. If you want the help words, I'm going to put them on now. And then I'll take you through the answers. So, direct current, DC, is a current that always flows in one direction around a circuit. It's supplied by cells and batteries. Alternating current, AC, constantly reverses in direction. The main supply to our homes is AC. In this case, the AC is supplied at an effective voltage of 230 volts and a frequency of 50 Hz. An oscilloscope can be used to display and measure a DC or AC waveform. So hope you found that introduction to household electricity okay. Thanks for watching, and I'll see you at the next video.